Okay, Calc, this is section 9.2. I'm going to go ahead and give you the notes for section 9.2. We still have a little bit left to finish on the notes in section 9.1, but that way tomorrow we can kind of do some damage control and figure out, what you guys still have questions on over 9.1 and 9.2. But I'll go ahead and give you these notes. I've got a sick kiddo here at home, so giving these notes to you electronically. Here we go. You guys should have a copy of this note sheet, and then you should also have a copy of the unit circle, which I think I made like purple color maybe. If you don't have both of those, they are sitting on my desk on my front table. Find those and fill these notes in as we fill them in, or as I fill them in on here. So the unit circle, this is your introduction to it if you've never seen it before. Unit circle, the equation is x squared plus y squared equals 1. And we kind of talked about last chapter that it was like x plus h was the center, or x plus h, y plus k told you where the center was at. And really this is basically like saying the same equation, y plus 0, x plus 0. Basically, the unit circle is centered at the coordinate point 0, 0, where the radius is 1. So 0, 0, radius 1. Here's your unit circle. They overlay radians on top of your coordinate plane here. So this is 0 or 2 pi radians. This is pi over 2, pi, 3 pi over 2. We talked about in section 9.1. The reason why 2 pi is used is because the circumference of a circle is 2 pi. Hey, no, you're being noisy. So there's just kind of some points that are good to know. The point 1, 0 corresponds to 0 or 2 pi. The point 0, 1 is pi over 2, negative 1, 0 is pi, and 3 pi over 2 is 0, negative 1. Those ones I want you to know. You should know those on the unit circle. In addition to that, I want you to know the coordinates for pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So they're either square root of 2 over 2, comma square root of 2 over 2, or positive or negative versions of that. So I want you to have those memorized. And then we'll talk about pi over 6 and pi over 3, how you get to those points. So be studying those so that you know those for sure. This is going to get pretty easy for you. Hold on just a second. Okay. So they ask for the 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent, those type of things. I didn't want to write them again over here because I'm lazy. So finding pi over 6 on your unit circle, he is located. This is just kind of trying to get you used to where things are located. So pi over 6 is the same as 30 degrees. Now, cosine corresponds to the x coordinate, sine corresponds to the y coordinate. So if we're looking for cosine of pi over 6, it's square root of 3 over 2, and sine is 1/2. So cosine is square root of 3 over 2. Sine is 1/2. Tangent, I think I also have tangent on there. Tangent is square root of 3 over 3. Kiddo. What? All right. Cosecant is the inverse of sine. So if sine is 1/2, cosecant is 2 over 1. Secant is square root of 3 over 2, or is the inverse of square root of 3 over 2. So this would be, I'm going to write it over here, 2 over the square root of 3. Now, if you leave it like that, I'll probably take off 1/2 point on your homework assignment or on a test or a quiz because you need to rationalize. So to rationalize that, we multiply by the square root of 3 over the square root of 3, and that will make it 2 square roots of 3 over 3. 2 square roots of 3 over 3. All right, so that was secant, and then cotangent. If tangent is square root of 3 over 3, cotangent is 3 over the square root of 3, or 3 square roots of 3 over 3, or just the square root of 3 when you reduce. So there's some rationalizing and some reducing that goes on to finding the cotangent. Okay, I'm going to go ahead and skip 2 and 3 because they're basically the same. The one thing that I will say about number 3, about pi over 3 is, or negative pi over 3. Negative pi over 3 is the same thing as positive 5 pi over 3. So you're just going clockwise, negative pi over 3 direction, that's 5 pi over 3. So when you're looking for that in your unit circle and you can't find it, that is why. That's kind of goes back to finding those coterminal angles. You add 2 pi to the 5 pi, or to the negative pi over 3, and that will give you 5 pi over 3. So just remember that. And then periodic functions, that's exactly what I just got done telling you. Basically, the period of sine and cosine is 2 pi. After you get through 2 pi, it basically, like, sine and cosine basically start over again. And if you can think about what sine and cosine look like on the graph, it's like a wavy, like a wave basically, and it starts over at 2 pi. So when we're looking for like sine and cosine of 13 pi over 6, you're probably not going to be able to find that on a unit circle. So we need to find an angle equivalent to 13 pi over 6 that's in the range from 0 to 2 pi. So I'm going to go ahead and I'm going to subtract 2 pi. And if we find a common denominator, that would be like subtracting 12 pi over 6, blah, which is just pi over 6. So then, after you get it to the relevant coterminal angle, then you can easily find sine and cosine from that. Negative 7 pi over 2, if I add 2 pi to that, that would be like adding 4 pi over 2. Okay, if you add 4 pi over 2, you're still at negative 3 pi over 2. Okay, but then I can add another 4 pi over 2 to that. And that would just give me positive pi over 2. And that is equivalent to negative 7 pi over 2. So once I get them to those equivalent coterminal angles, then I've got sine and cosine. To find that is fairly easy. Okay. Next page, flip over. Even and odd functions, I give you a little background information on even and odd functions. We kind of talked about this before. This is kind of like basically the same as lines of symmetry. So if we're trying to figure out whether something is symmetric with respect to the y-axis, we plug y-axis. We plug a negative in for x. And then if it is the same as the form it was to start with, then it's symmetric with respect to the y-axis. Well, those are special functions, and they are even functions, like y equals x squared. Like y equals x squared is an even function. If I plug a negative x in there, negative x squared is equivalent to just positive x squared, so y equals x squared is an even function. Odd functions would be like y equals x to the third power, where if I plug a negative into the function, it turns the entire equation negative. Like negative x to the third power stays as negative, so this negative pops out front, basically. And you can kind of see the way that that works with the coordinate points. The point 2, 8 on the graph of x to the third power becomes negative 2, negative 8 down here. And then the point negative 2, 4 and positive 2, 4 on the y equals x squared. So even and odd functions, those are the definitions of even and odd. Cosine and secant, those are, what is the deal? I think you're just trying to make sure you know you're here. Yeah. Cosine and secant are reciprocal functions. Cosine is an even function. Sine and tangent are odd functions. And let me kind of show you how this works. It says that cosine of a negative value just turns it back positive. Sine of a negative value makes the whole thing negative. So that's the definition of odd and the definition of even. So let me kind of show you what's going on here. I took just 1 point or 2 points basically off of your unit circle. This is 45 degrees and this is negative 45 degrees. It's also like 315 degrees if you want to refer to it as that. instead, which is negative 45 degrees. Find those on your unit circle so you can see them. We have cosine of negative 45 degrees. My lord, kid. I'm the noisiest thing. I promise all my videos won't have my children in the background, hopefully. So cosine of negative 45 degrees right here. Negative 45 cosine is the x-coordinate. That is the same as cosine of positive 45 degrees. Square root of 2 over 2, square root of 2 over 2. Done. Now sine of negative 45 degrees is the y-coordinate. Sine is negative square root of 2 over 2. That's the same thing as negative sine of positive 45 degrees. We just took that and we put a negative in front of it to get this. Tangent of negative 45 degrees, this is negative 1 down here. And tangent up here is a positive 1. So tangent of negative 45 degrees is negative 1, which is negative tangent of positive 45 degrees. So you can kind of map that out with just those 2 points. It's the same for any, like I could have done 60 degrees and negative 60 degrees, or 120 degrees and negative 120 degrees, whatever. That would work the same, but those are even and odd functions. Even basically is symmetric with respect to the y-axis. Odd is symmetric with respect to the origin. I didn't write that down. Origin. So basically what we learned in last chapter with y-axis and origin symmetry, that goes back to even and odd functions. So there you go. We're going to talk a little bit more about, and I'm going to make you memorize a little bit more of this unit circle after we do section 9.3. So get prepared for that. If you want to start studying this unit circle, go for it. But I'll show you some tricks and stuff as to how to remember what's on this unit circle and stuff. So homework is page 580, 8 through 48 by 4, 62 through 66 evens. And that is all I have for you. Okay, we'll come and answer questions tomorrow. Hopefully I'm back tomorrow.